Okay, so I am continuing with every exam question that's been asked, and we're now moving on to quadratic equations. This is testing everything from Edexcel between 2017 and 2021. If you like this, make sure you're subscribed. It's going to be really, really useful to have all of these videos being covered. So let's get started, and we're going to have a look at quadratic equations. So let's open this up. Now this document is available, it's in the description, and there's a link so you can download this and it's fully hyperlinked. So there's going to be some questions where there's no context, and then there's going to be some where there is some context, and they do get pretty tricky. So I'm going to start off with a nice easy one. It says solve x minus 2 squared equals 3. Give your solutions correct to 3 significant figures. Now I've seen people do this kind of question before and they think, oh, I better expand the brackets and make it look like a normal quadratic being equal to 0. But actually, it's already in a form that we can solve. We can get rid of this squaring by square rooting. So if I square root this side, I also have to square root this side. But remember, you could have the positive and negative versions. So this is going to give us that x minus 2 is either the square root of 3, or x minus 2 is the negative square root of 3. So all I'm going to do for this one is I will add 2 to the other side, so I get the square root of 3 plus 2. And over here I get the negative square root of 3 plus 2. Because it wants it to 3 significant figures, I'm going to type that into my calculator. So I'm going to do the square root of 3 plus 2, and that is to 3 significant figures, 3.73. And then I'm going to do the negative square root of 3, negative square root of 3 plus 2 for the other one. And that is going to be that x is 0.268 to 3 significant figures. So you didn't need to expand the brackets for this, and those are our 2 answers that we've got there. Okay, this one is kind of a more traditional one, and it's a non-calculator one, so we are going to make this equal 0. So I'm going to do x squared minus 5x minus 24 equals 0, and then I'm going to try and factorize. So I need to think of 2 numbers that multiply to negative 24 but add to minus 5, and those 2 numbers are going to be minus 8 and plus 3, because they multiply to minus 24 and they add to minus 5. And now it's just as simple as saying either that bracket's equal to 0 or that bracket is equal to 0. Well, if this bracket is equal to 0, that would mean that x is 8, and if this bracket was equal to 0, x would be equal to minus 3. So our answers are 8 and minus 3. Now we've got one that sort of gives us a bit of a clue here. We've got like an equation that doesn't look like it's going to be factorized because it says to give your solutions correct to 3 significant figures. There's also this other big clue that it's the quadratic formula. So the quadratic formula says that x is equal to minus b plus or minus the square root of b squared minus 4ac all divided by 2a. And when we're talking about a, b and c here, we're talking about a, b and c. So a is 5, b is minus 4, and c is minus 3. Now, most of the time they've been giving this formula. Because of the pandemic, they've been trying to make it a little bit easier with a formula sheet, but at some point they might not be giving this. So we're going to substitute in the values. Now, b is negative 4, so negative 4 is just 4. And that's plus or minus the square root of. I don't like typing this all into the calculator all at once. I like to do it a little bit at a time. So negative 4 squaring, when you do negative 4 times negative 4, you get positive 16. And then you've got minus 4 times by a, which is a 5, times by c, which is a minus 3. And that is all going to be divided by 2a, which is 10. So I'm going to put this into the calculator, first of all with the plus sign, and then I'll do it with the negative sign. So when I put this in the calculator, I am going to begin by doing my fraction button, and I'm going to do 4 plus the square root of 16 minus 4, brackets 5, brackets minus 3. And then on the bottom, I'm going to put 10. Now to 3 significant figures, that is 1.27. Now I'm going to go back through the calculator, and I'm going to change it from a plus at the beginning of the square root to a minus at the beginning of the square root. And to 3 significant figures, that is 0.472. So those are our 2 solutions that we've got there. 1.27 and minus 0.472. Okay, let's now try this one. It's mixed with some ratio. Now all we need to know with ratio is if we do that one divided by that one, it's the same as that one divided by that one. So x squared divided by 3x plus 5 is equal to 1 divided by 2. Now the 3x plus 5 is going to go up there, and the 2 is going to go up to the other side as well, which gives us 2x squared equals 1 multiplied by 3x plus 5. Now we're going to make this like a quadratic. We're going to put it all on one side, so we get 2x squared minus 3x minus 5 equals 0. And now we have to try and figure out what to do. Now, because of the fact that it is a non-calculator paper, it's making me think this shouldn't use the quadratic formula. So I'm going to do the kind of factorizing process. Now, I have got videos about how to do these, but I use the method where you multiply the a term by the c term, where you do your a times c. So a times c in this case is minus 10. And we need to think of some numbers that multiply to minus 10, but they add to the one in the middle. Sometimes people call this the MAM technique because it's multiply, add, multiply. So you multiply those two, and you need to find something that adds to the one in the middle. So to add to minus 3, but multiply to minus 10, I think it's going to be minus 5 and 2. Yep, they're going to work. So you take this minus 3x in the middle, and you're going to split it into two things. You're going to split it into a minus 5x and a 2x. Of course, we've still got the 2x squared and the minus 5 there. Now what I'm going to do is I'm going to factorize the first part, and that is going to be the highest common factor of an x, which will then be a 2x minus 5. And then for this next part, well, I definitely want there to be another 2x minus 5, and we think, well, what's going to be the thing that's outside the front? Well, it actually ends up being a plus 1. So one of the brackets is a 2x minus 5, and then the other bracket's what we've got left over, which is the x and the plus 1. So we have x plus 1 equals 0. Now, this tells me something. Let me just make a little bit more space for myself here. See if I can squeeze these lines up so that I have just a tiny bit more. This now tells me that either this is equal to 0 or this is equal to 0. So we either get that 2x minus 5 equals 0, which means that when you add the 5 and divide by 2, x is 5 over 2, or x plus 1 is equal to 0, which just means that x is equal to minus 1. So our answers are x is equal to 5 over 2, or x is equal to minus 1. So just double check that this works. Yeah, that does work. Good. So we've got minus 1 and 2.5, or 5 over 2. All I was doing was just thinking when you sub them in, does it still give you that ratio of 1 to 2? I wrote 5 over 2 instead of 2.5, but whatever you prefer is fine for that. Okay, now we're going to some quadratic equations with the areas of squares. Let's read what it says. Well, it says the length of each side of square B is 4 centimetres greater than the length of each side of square A. The area of square B is 70 centimetres greater than the area of square A. Find the area of square B. Okay, there's a lot going on here, but it says that the length of each side of square B is 4 centimetres greater than that of A. So if I called A x and x, B would be an x plus 4 and an x plus 4. And it says the area of square B is 70 centimetres greater than the area of square A. So for square A, the area is just x times x, which is x squared. And for square B, the area is going to be x plus 4 multiplied by x plus 4. So I'm just going to quickly work that out. That's going to be an x times x, then we're going to have a 4x, and a 16, which is x squared plus 8x plus 16. Now we're going to read this sentence again. It says the area of square B is 70 centimetres greater than square A. So that means that x squared plus 8x plus 16, that is the same as the area of square A, but with 70 extra. So now all we're going to do is actually solve this equation. And even though it comes up in quadratic equations, because it's an equation with some quadratics, we actually get some stuff cancelling here. So I can subtract x squared from both sides, and I get left with x squared plus 16 equals 70. Now it's a calculator paper, so if you want to, we can do this last part on the calculator. I'll do 70 take away 16, which is 54. And then I'm going to divide that by 8. So I get x is 6.75. Now all I need to do is find out the area of B. Well, it is 6.5 plus 4 times 6.5 plus 4. So if I just quickly think about what it would be at the top, if I add 4 to that, that must mean it's a 10.75 here and a 10.75 here. So the area of B is 10.75 times 10.75, or 10.75 squared. And 10.75 squared is 115.5625 But let's check what it said. It says give your answer correct to 3 significant figures. So when I round that to 3 significant figures, I get 116 centimetres squared, and I'm just going to write that that is 3 significant figures in brackets. Let's double check we've got this right. Good, we've got the 116 that was there and the mark scheme in case you want to pause it and check that you've got the same sorts of things and where the marks are actually coming from. But I sometimes find these are a bit difficult to read, which is why I wanted to make sure you had these to look at too. Okay, the diagram shows a right angle triangle. All the measurements are in centimetres. The area is 27.5. Work out the length of the shortest side of the triangle and you must show all your working. Well, we know that the area of a triangle is the base times the height divided by 2. And in this case, it is equal to 27.5. So if I do the base, which we could say is x plus 4, we multiply that by the height, which is x minus 2, and we divide that by 2, we get 27.5. So first of all, I'm going to do the 27.5. I'm going to times that by 2, which is in the denominator. So 27.5 times 2 is 55. So on the right-hand side, I've got 55. Now I'm going to expand these brackets that I've got at the top. So we get x times x is x squared. X times minus 2 is minus 2x. 4 times x, and then 4 times minus 2 is minus 8. So that's x squared. The x parts simplify to 2x, and that is minus 8 equals 55. Now, because it's a quadratic, we're going to make it all equal 0. Tell you what I'm going to do. I'm going to take this and put this down here. So I'm going to do minus 8 minus 55. So I'm going to do x squared plus 2x minus 8 minus 55. Well, that's actually like a 55 plus 8, and then just make it negative, and that's going to be minus 63 equals 0. So continuing with the working here, because it's non-calculator, I think we're going to be able to factorize this. So I'm going to think of two numbers that multiply to 63, but add to 2. And those two numbers are going to be 9 and minus 7. Because they add to they multiply to minus 63, but they add to 2. So this tells me that a solution is x equals minus 9, and this tells me that the solution is x equals 7. Well, it doesn't make sense if x is minus 9, because you would have minus 9 minus 2, that would be a negative, and here you'd have minus 9 plus 4, that would also be a negative. So this one here doesn't make sense, so just a simple line going through it. So this must mean that x is equal to 7, and we're looking for the length of the shortest side. So the shortest side is x minus 2, which is 7 minus 2, or 5 centimetres. And there we've got our 5 centimetres. Okay, we have got a few more of these to go. This one is pretty hard. So it says the diagram shows two shaded shapes A and B. Shape A is formed by removing a sector of a circle with radius 3x minus 1 from a sector of the circle with radius 5x minus 1. Shape B is a circle of diameter 2 minus 2x. The area of shape A is equal to the area of shape B. Find the value of x. Wow, there's a lot going on here. Well, this is 45 degrees. So the first thing that that's telling me is 45, and it's a non-calculator paper. 45 degrees out of 360 degrees is 1/8. So it is 1/8 of a circle. So when I find the area, I'm going to divide it by 8, either at the beginning or at the end. It doesn't really matter. So I'm going to begin by doing like the full kind of wedge shape, which is for this whole distance that we've got along here. And that whole distance is a 3x minus 1 plus 2x, which is 5x minus 1. So the area of this is going to be pi times by the radius squared, and that's all going to get divided by 8. So I'm going to quickly just work out what 5x minus 1 squared is. Now this is right near the end, so you need to know how to do this pretty confidently. 5x minus 1 squared is going to be 25x squared. You're going to get a minus 5x and a minus 5x, which is minus 10x. And then we're going to get a plus 1, and that's being divided by 8. Now what I'm going to want to do from that is I'm going to want to remove that little small section that we've got, and that small section is just a 3x minus 1. So the area of that is going to be pi multiplied by the 3x minus 1 squared, all divided by 8. And if I squeeze that in here, that is going to be, if you expanded those double brackets, 9x squared minus 6x plus 1. And that's all divided by 8. So we're going to have to see how much we can fit this in. I might see if I can actually just shrink this down for a second so that I can get more working out in. So I'll do some working and then I'll squeeze it in. So now we're going to say that the area of A is going to be this one take away this one. So that is, let's just concentrate on the quadratic part. We're going to do this one, take away this one, and then we can just put them together. So there's definitely going to be a pi over 8, but the quadratic bit is going to be 25 take away 9, which is 16x squared. Or shall I write it out? Yeah, I'm going to write it out. So we've got 25x squared minus 10x plus 1, and we're going to be subtracting all of this. Now when you subtract that, you're going to subtract a 9x squared, but when you subtract a 6x, it becomes a plus, and then we're going to subtract a 1. So that is pi over 8. 25x squared minus 9x squared is 16x squared. Then we have here minus 10x plus 6x is minus 4x. And then we've got the 1 and the 1 cancelling out, luckily. Whew. Let's shrink this down so that we've got some more space. Okay, I'll see if I can put that in this section. Okay, so now we're going to work on area of B. Let's do this at the top. Now the area is pi r squared, so we need to figure out what the radius is. Now if this is the diameter, the radius will be half, which is just 1 minus x. So the area of B is just going to be pi times by the radius squared. Now 1 minus x squared is going to be 1 minus 2x plus x squared. If you need practice on expanding double brackets, I can't do that in here because we're just going to run out of time. Now we've said that the area of A is equal to the area of B. So this expression that we have down here, which is our pi divided by 8, 16x squared minus 4x, is equal to pi multiplied by 1 minus 2x plus x squared. So I'm going to divide both sides by pi so I can get rid of that. And I'm also going to get this 8, I'm going to multiply it up to the other side. So that I get 16x squared minus 4x. I'm going to multiply everything by 8, so that's 8 minus 16x plus 8x squared. Now I'm going to subtract the 8x squared from this one, so I get 8x squared. I'm going to add 16x, so I get plus 12x, and then I'm going to subtract 8. Now this equation, including the 0, everything is going to get divided by 4 to simplify it. So when I divide that by 4, when I divide that by 4, and when I divide that by 4, I get this. Now to save us a bit of time, we're going to figure out what this will factorise, almost like with a guessing kind of technique. I know that one of the bits is going to be a 2x and an x, and it's going to be like a 2 and a 1 kind of thing here. So I think it's actually going to be a minus 1 here and a plus 2, because I will get 4x and minus x. 4x minus x is 3x. I get the 2x squared and I get the minus 2. So we're nearly there. Now either this tells me that x is equal to minus 2, but that doesn't make sense, or this one tells me that x is equal to a half. So the only one that works here is a half. So I'm going to take all of this stuff that we've got here, I'm going to resize it so that it kind of matches up with the other stuff that we've got. And that is a tough question for 5 marks, but we should get that x is equal to 0.5. Okay, we have got just one more question, so we'll go as quick as we can here. Given that tan E equals tan F, find the value of x. Well, the tan of E, remember that tan of theta, or tan of x, whatever it is the opposite divided by the adjacent. So when we do tan E, let's just quickly jot down what that would be. Tan E is the opposite, which is x, divided by the adjacent, which is 4x minus 1. And tan F is going to be the opposite, which is 6x plus 5, divided by the adjacent, which is 12x plus 31. So that means x over 4x minus 1, which is tan E, is equal to tan F, which is 6x plus 5 over 12x plus 31. The 4x plus 1 is going to go up there. The 12x plus 31 is going to go up there. So that's x multiplied by x multiplied by 12x plus 31 is equal to 6x plus 5 multiplied by 4x minus 1. I think I'm going to do some shrinking down on this one in a second as well. So I'll expand the brackets on the left-hand side. We get 12x squared plus 31x. And when we expand the brackets on the right-hand side, the 6x times the 4x is 24x squared. The 6x times the minus 1. the 5 times the 4x, and the 5 times the minus 1. So I'm going to put everything all on the right hand side. So I'll do my 24x squared take away 12x squared, which is 12x squared. And then it's a calculator one, so I've got my minus 6x, so that's my minus 6x, my plus 20x, and I'm also going to want to subtract that 31 as well. So I'm going to subtract 31x, and I get minus 17x. And then all I've got left over is the minus 5. So we now need to try and factorise this or use the calculator to do it. I think I'm going to try the factorising method. So we need to think of two numbers that multiply to minus 60, but they need to add to minus 17. Now, I've quickly spotted it's going to be minus 20 and 3, and that's going to help us do the factorising process. So that means we're going to split the 17 up into a minus 20x and a plus 3x, and we have a minus 5. Now we're going to factorise as much as possible with this. I think the highest common factor is going to be a 4x. So that's going to be 4x multiplied by 3x minus 5. And then this part is going to just be a one lot of 3x minus 5. So continuing this up here, that means that we get 0 equals, the first bracket will be 3x minus 5, and the second bracket is 4x plus 1. This means that x is equal to 5 over 3. This one means that x is equal to minus 1 over 4, because we're making the whole bracket equal 0. But this second one doesn't make any sense, so the value of x is going to be 5 over 3. The reason it doesn't make any sense is we can't have a negative value for x in this particular thing. So the only answer that we've got is 5 over 3. Wow, this question and this question were pretty tough and a lot of working out. So that is everything about quadratic equations that has come up. They do pop up in some other places as well. In the next video, I'm going to be doing some things on simultaneous equations.